right, so in the previous 3 sections, we've been studying vectors, right, and things we can do with it. Right, so let's study another thing we can do with it, but this one is more geometric and actually visualizing things. Right, so a vector, is basically an arrow in some sort. And what we can do is just sort of, well, vector, we see like a piece of a line. Let's just kind of stretch it all the way out and make an entire line. So something like this. Right? So this is a line that, well, when we draw something on a board, maybe it looks like 2-dimensional, but it could be floating around anywhere in 3-dimensional space. So how can we describe such a thing? Well, this vector here sort of tells us the direction we can move, right? And then if we imagine this vector starting at some point P here, and let's give this vector a name 2, call it V, right? Then we can imagine sort of taking 2 times this vector, and it would give us this, and then double it out here. If we did negative V, it would start at P and go about there, right? So we can use multiples of V to span this whole line, right? And the way we can think of that is to actually graph this in, x, y, z coordinates. The way we should think of this is, let's say P is a point x naught, y naught, z naught, right? And V is going to be our vector A, B, C, right? And then what we want to do is sort of describe a way to start at P and then move in the direction of V in either way. Right? And moving in that direction is just going to amount to adding some scalar multiple of this vector. So let's say we want to call the line, let's say R of t. Right? And since we're dealing with vectors here, we're going to put this little hook or arrow sort of thing above the R here. Right? Now we want to start at P. So what we should do is just, well, start by writing P. Right? So since we're using vectors, we're going to change these parentheses to the vector notation. So, sorry, not A. X naught, y naught, z naught. Right? So that starts us here at P. Right? And then from there, we just have to add multiples of V. So, well, let's start by adding just V. Okay? And we get something that looks like this. But I want to be able to add any multiple of it. So I'm going to put a t in front here. Right? And that's the same t here. So this describes the line as sort of a function. Right? So if we graph this R of t here, we'll get the equation for the line. A nice sort of way to remember this, instead of just trying to look at this formula here, we can think of this as just sort of point plus t times direction. So that's maybe here, let's call this the starting point. And V, remember that's how we move along this line, that's the direction.